A weather map is constructed by plotting around each reporting station the different observations made at that station. By the system employed and the use of symbols, the large amount of information reported to the forecaster can be plotted in small compass over each station. The figures of any particular element are easily picked out because of their position relative to the station. For example, because of their position, the forecaster knows that these figures refer to pressure. Examination of the collective barometer readings reveals that over South Scotland and North England, pressure is below 990 millibars, the initial 9 being understood. In other areas, it is higher than this. Between the region where pressure is below 990 millibars and that where it is above 990 millibars, there must be places where pressure is exactly 990 millibars. The position of the isobar of 990 millibars is obtained by interpolation. Isobars for other pressures are similarly obtained. It may happen that the isobars form closed curves round an area of low pressure. Such an area is called a depression, or low. The next most important element to the forecaster is temperature. Temperature is shown to the top left of the station circle. It is plotted in degrees Fahrenheit. An examination of the temperature distribution reveals that to the north of the line shown, the air is relatively cold, while to the south, the air is relatively warm. The figures specifying dew point are shown in red at the bottom left of the station circle. Dew point is also plotted in degrees Fahrenheit. A comparison of dew point readings reveals that to the north, the dew point is relatively low and the air comparatively dry, while to the south, the dew point figures are higher where the air is relatively moist. Wind direction is shown by an arrow flying with the wind. Wind force is indicated by the number of bars. It will be seen that there is a marked difference in wind direction between the relatively cool, dry air and the moist, warm air to the south of the line. It is obvious, therefore, that the line shown is a boundary between air masses not only with different temperatures, but with different general characteristics. Air which has remained for some time in polar latitudes will have acquired the low temperature and low humidity characteristic of these latitudes. It is called polar air. Polar air may arrive over England following a very direct path. Such an air mass will have its characteristics only slightly modified. Polar air traversing a large expanse of ocean is heated by contact with the sea and is further modified by picking up moisture. Such an air mass is classified as maritime polar air. Polar air which travels over the extensive land mass of the continent remains dry. It is very cold in winter, but may be heated considerably in summer. Such an air mass is classified as continental polar air. Air which has remained for some time in tropical latitudes will have acquired the high temperature and high humidity characteristic of these latitudes. It is called tropical air. Tropical air may originate over an area far to the westward of the area shown. Tropical air, in the course of its movement into temperate latitudes over the ocean, is cooled, and its relative humidity is increased. Such an air mass is classified as maritime tropical air. Tropical air reaching temperate latitudes after traversing the continent is cooled, and in winter it will have lost some of its moisture in rainfall on the way. In summer, it may be very hot and dry. Such an air mass is classified as continental tropical air. Air mass analysis is of fundamental importance in modern forecasting. Very often, the distinctive characteristics of polar and tropical air are retained, and the transition from one air mass to another may be relatively sharp. So sharp, indeed, that it may be represented on the weather map by a line. The difference in the direction of movement of the two air masses may be merely relative. Such a line is called a front. The front at the surface is the boundary between these two air masses. But this boundary extends into the upper air and may be considered as a sloping surface, the cold air lying under the warm air in the form of a wedge. Depressions frequently develop at a front. A wave-shaped distortion of the front occurs. This is associated with a local fall of pressure, and a depression develops in consequence. Continuous deepening and development of the depression then takes place over the area shown. Circulating winds develop around the depression, further distorting the shape of the front.